Here there's an interesting chart. This is in yellow, the little bottom one in yellow. This is what the industry, as of today, is ready to produce by 2030 in millions of square meters of dynamic glass, so including SPD, electrochromic, etc. At the moment, we didn't hear anything about those big names to put new electrochromic factory or etc. The two other boxes at 10 million a square meter and 30 million a square meter are the expected demand. 10 million is the expected demand with the current cost price. 30 million is if you drop the price down, that could reach that for basically tomorrow, 2030. I mean, the time you build up factories to cover this. So already at this stage, if there is no new factories built up right now, you will even not cover the demand for 2030 because you won't, even if the technologies are great, you won't be able to produce them at the right volumes. So there's a bit of an issue there. And how can we impact the climate if we even didn't run our economies that we can build the factories to supply the demand, to make that change? But what's behind this, and that's why it excluded the liquid crystal and the gas house LCD production capacity, the display industry is 400 million square meters production per year, with, at the moment, 60% load. So 40% of that capacity is ready right now. And who is the number one supplier of the display industry? The glass industry. It's all based on glass, those displays. So it's really a long partnership between the two industries. You want to cover the demand for 2030? Don't build new fabs. The fabs are there. But the technology that we develop for dynamic glass needs to adapt to those fabs. And that's what we aim for at Elstar for some times. Now, if we look at the emerging technologies, what I noticed, so they are in the emerging, and you can see that at the startup event. We have the electrochromic, there is some progress there to make it more color neutral, to make it less costly to produce, going to weight processes, etc. All of this is great, but again, how are we going to deploy the industrial need for 2030 in terms of productions? How are we going to make those surfaces of glass? And you have two technologies also on the booth there. So there is the metal electrodeposition, and there is Elstar, the electrophoretic element. And both of them have very good dynamic range because, again, with the paradigm I talked about how to create the color versus to rotate the elements or displace and creation of elements. But basically, one commonality between these two techs is also they required a metal pattern to be effective. So now let's question ourselves. We have two of the three coming technologies for dynamic glass. They include metal patterns. There's maybe, I mean, we didn't consult each other for that. Huh? Let's be clear. Huh? There's maybe something behind this. Usually, we don't like metal pattern. I heard that this morning for another talk around PVs because it impacts the artifact, the optical distortions. And fair enough, but the question, think about mass market volumes. How are we going to achieve it? Because what counts more at the end? Do we save the planet or not? And yes, this will have an impact, but I would say any dynamic glass will have an impact on it. There will be always an impact on transparency. There will be always an impact on colors, on haze. So at the end, what's more important? I would say, is the curtains much better? I can tell you this picture is at our office. The curtain is a kind of a grid mesh. It's absolutely horrible to see through. But it's our current dynamic, it's our dynamic curtain automated via the building. So the question is, well, we accept that. So the question is, you know, why being afraid about the metal patterns? In fact, they can be engineered and worked out to be almost perfect. I mean, that's also one of the key advantages. But then where we think there's a massive entrance we can do with dynamic glass is to make it self-powered. Because at the moment, that's also a barrier to enter the market. If the dynamic glass is not self-powered, you need to put together somebody from the glass installation and somebody from the electrical installation. Nobody wants to take care of the warranty. It's just an entry barrier that is problematic. And our job is to make sure that we remove all entry barriers. One way, as we have seen this morning with a great talk, is going via photovoltaic integration into the windows. So we have seen very nice solutions very transparent. I think that they're really great. And I would say they are very applicable for all dynamic glass, including L-star dynamic glass. But there's still always a question about the impact on the maximum transparency. So for example, this morning we heard a 70% transparency. I think that's brilliant for a single technology. But as soon as you combine with another technology, if your dynamic glass is 70%, okay, that's 70 times 70. Oh, that starts to be low. Oh, but I need to put the PVB, I need to laminate, there is the glass. It's going down and down and down. It's kind of a problem. I mean, how do we combine all these tech together without killing the optical efficiency? And what we think we should do is to use the metal arrays that we have, which are dead areas, which are the area that makes sometimes life a bit more difficult from an optical point of view. But in fact, they are the solutions. Because as soon as you pattern your system, your photovoltaic system, on the metal arrays area, it's a fantastic solution because it's well-known cost, the production is known, you can use standard photovoltaic, every part, amorphous silicon, crystalline silicon, all of that is compatible with the production. You can use CIGS, CDT, whatever you want, and whatever coming on the way. You're not restricted anymore to having a transparent photovoltaic material. So we believe that making that patterning is a very good asset for dynamic glass, especially for the one with metal arrays. So if we sum up, and of course, I'm working for L-star, so the ELM at the end is all green, but I truly believe in it. The dynamic range is demonstrated to be at the right level from privacy to full transparency. The cost will be at a very low level, and we're going to see that. The production scalability is there. The sustainability is there. We only use metal, glass, metal trikes, glass, and electrophoretic ink, which is like a paint, super safe, all under rich European regulation. And we can integrate PV that is scalable with completely known PV. We don't have to invent anything there. So let's get through a little bit more about electrophoric light modulator. So we have a very strong contrast. We can modulate every grayscale in between. We can modulate both the visible and the near infrared at the same time for the moment, but as it's based on paint and pigments, we can split that in the future, which is also quite essential. I mean, the technology, dynamic glass, that will make it is the one that split the two. It's based on pigments, and it's fully adapted to the LCD manufacturing. So we're not liquid crystal, but we use the same fab. And that's where we're going to kill the cost and the scalability. So this is the schematic. I'm going to go through not too long on it, but basically two pieces of glass because it's used in the LCD fab. But it could be any substrate. We also accommodate to plastic, so we can produce it flexible. It's just a matter of supply chain and developing the production for that. For the moment, the TV production is based on thin glass. We are doing on thin glass. We have two sets of electrodes facing each other, some spacering to maintain the substrates far away from each other, an electrophoretic ink produced by L-star. And when we apply an electric field between the two electrodes, top and bottom, the pigments are grouping behind the electrodes, leaving a space in between with only the transparent liquid, so you're super transparent. So your transparency level and your dynamic range is modulated both by the ink, but also the way you design the cell, the distance between the plates, the distance, the size of the electrodes, the shape of the electrodes, their distance, the voltages, all of this have different implications on the performance. Just a quick video to show you the performance. So basically, this is one of our latest demos. It goes from 0.1% black to 65% transparency within 45 seconds. And all of this can be tweaked. And I think when people from augmented glasses reality, they ask us to make a black modulator for them at half a second time, I think it's challenging, but it's not impossible. It all depends how we design everything. But you can see the clarity, the color neutrality, and we already worked out very strongly about all optical effects because this glass is 30% covered with metal. 30% of that surface can be utilized for other things. And that, so here you have the spectra. So as you can see, for the dark blue, this is the transmittance of the non-laminated, we also start laminating using some PVBs. You see the impact. That's the production as we do now. So 2 substrates, patterned, facing each other. So very standard process for the LCD industry. And we just use their one-drop filling, so we make sure that the ink adapt to the machines and they can produce like they used to do. So usually we provide the ink, 2 weeks later you can get your modules, because not only we utilize the machines they use, but you also utilize their standard processing. So when we go to manufacturer, when they ask which electrode do you want, we ask what is your standard? Which metal is your standard? What is your thickness standard? And we just go on, because as soon as we're conductive, we're good enough. And metals are just good enough conductive for that. We are based on pigments and not dyes. I mean, we got an interesting comment this morning about a representative of Merck who was saying that you should never put dyes into a facade. I spent 12 years on dyes. I can only agree with that. They will bleach. So pigment is essential. So it's based on pigment. We can do any kind of colors. At the moment, we really focus on black because, again, this is the mission to make it mass market. So there is one focus, but fundamentally, you can do any colors. And also non-transparent colors, like a pure infrared modulator, because pure infrared pigment does exist. That's the kind of integration to double glazing unit. We have a great dynamic range on G values. But again, it's all about the constructions, etc. We are not expert in Windows, so we flag this because but this is where we need more support from other parties. We are really specialists more on the display side. And then, as I mentioned, it's about PV integration. So what we have done is we have just simulate, if we use a standard PV, like let's say 20% efficiency with the current 30% coverage, looking at different cities with the solar irradiations, compared to our power consumptions required for the window, how much extra electricity we can generate, how many number of days consecutively will be not enough in energy. There will be some energy, so you can compensate with batteries. But, you know, you can, so I'm sorry, but in Tampere, it's not very ideal for that, I have to admit. This is the worst case. But I would say everybody else in the world, I mean, in the region more further, it's compelling. Basically, by integrating standard PV, you can get them at very low cost in the system, because standard PV like amorphous silicones are even the base of the TFT pixels based in LCD TV. So for them, adding this function is barely at no cost. And that's what we can bring by utilizing the LCD factory, is getting more and more. And basically, I would like to finish with this slide, is what we believe is dynamic glass. Maybe also don't make it mass market at the moment, because as a single solution, compared to the cost, is not enough. But the advantage of using an LCD fab and coming with a technology like ours based on metal arrays is you can put multiple functions at the same time for merely the same cost, because they're already integrated into their production flow. Like a photovoltaic, but you can utilize the electrode to harvest the energy, because that will help killing the big heat insulation from the glass, because you can transmit it via the surface. You can integrate antennas to make it a communication partner. Or you can also adapt it to transparent displays, because currently a lot of displays are created, micro LED, OLED displays, all based on these pattern pixels and TFT metallized system, where if you just put an LCD backlight behind, you just kill the overall transparency. You need a system that is working the same, and that's what we propose. So that means your window can be everything at the same time, produced at the same time. So 2 pieces of glass that's doing light modulation, generating electricity, transmit radio frequencies, and as well generating light. It's just working with LCD manufacturer and basically partnership with other technologies, but all within one product at a cost that will just be way under any other cost that is currently based for dynamic glass. Because current production cost of TVs, I mean, the LCD TV is $100 a square meter as we speak. There is some wave depending on the events like COVID. Sometimes it goes up to $150, but that's the range. So we are far away from the $800 square meter that is the minimum for an electrochromic as of today. And again, the production is in place. So thank you for your attention. I think I'm just 20 seconds off. That's good. If you have any questions, thank you.